Hello, welcome back. And this video will focus on the graphs of the 6 trig functions. We want to keep a couple of things close in mind. One of them is the domain of each function, the other is the range of each function, and lastly the period. And as you'll see, these graphs will begin to repeat themselves after a while, and that's what period is all about. So let's begin and put the graphs up, and we'll talk about them a little bit. So the first two to look at are sine and cosine. And remember how these are defined. Again, everything goes back to that definition. At 0, sine is 0. And then it goes to 1, 0, minus 1. And then at 2 pi, it's back to 0. Cosine starts at 1, goes to 0, minus 1, 0, and then back at 2 pi, it's at 1. So let's just make sure that we organize our thinking for sine and cosine to begin with. So as I said, domain, range, and period are important. And when we look at sine, x, the domain, what we can take sine of, and cosine, is any real number. I believe we've already said that. So the domain of each of these is all real numbers. And again, notice that for sine goes from minus 1 to 1, cosine goes from minus 1 to 1, and that's it. So they both have the same range. Minus 1 to 1, including those endpoints, minus 1 to 1. So this is maybe the first time we've talked about period, using that term, but we talked about the wrapping function. And here we are at sine at the beginning. Here we are at pi over 2, pi, 3 pi over 2, and 2 pi. Same thing with cosine. It takes 2 pi units for each of those to begin to repeat. And so each of them have a period of 2 pi. And those are our most basic graphs and the most important ones. And notice that really they're the same graph. I mean, if we were to take cosine and just shift it pi over 2 to the right, or take sine and shift it pi over 2 to the left, these two graphs are exactly the same. And if you think about, again, how the unit circle changes, that will also help you believe that. So let's look now at the other 4 functions. So these graphs are a little bit different. Tan and cotan kind of look the same, and cosec and sec kind of look the same. Let's talk first about their domain and range. So here's the way we define tan and cotan. Now, tan will not be defined when cosine is 0, and cotan will not be defined when sine is 0. Now remember, where is cosine 0? Pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, minus pi over 2, minus 3 pi over 2, so on. When is sine 0? At 0 and pi and 2 pi and 3 pi and minus 2 pi and so on. So if you keep that in mind, that will help you understand what the domain is for each of these. But take a look at the way these graphs go. The range of both tan and cotan are all real numbers. So let's try to organize this in a little bit of a chart. So to begin with, let's fill in this chart. Let's leave domain for the end, but the range of tan and cotan is all reals. The period, now take a look. Here we are at one chunk of tan, and all it takes is pi units. Same thing with cotan. So for each of those, the period is just pi. Now, the domain. Domain for tan of x is all reals except those values of x which make cosine equal to 0. And the way we can write that is all reals except multiples of k times pi over 2, where k is not 0. Similarly, for cotan, the domain is everything that except those values that make sine equal to 0. So that's going to be all reals except multiples of k pi, where k is not equal to 0. And there we go with a complete chart for tan and cotan. And then we'll finally look at cosecant and sec. Okay, so let's remind ourselves what cosecant and sec are, how they are defined. So cosecant is one of a sine, and secant is one of a cos. Now let's just kind of do a little bit of remembering. Remember, sine is only between minus 1 and 1. So therefore, when we look at 1 over sine, it's all either going to be greater than or equal to 1, or less than or equal to minus 1. And similarly, sec is going to be greater than or equal to 1, or less than or equal to minus 1. The domain, we've already sort of talked about this. All the values for x for which sine of x is 0 have to be excluded, and here we exclude all the values for which cosine of x is 0. Notice also that cosecant and secant have asymptotes at the values where sine and cosine are 0, just like tan and cotan have asymptotes at similar values. So let's fill in the chart for cosecant and secant. So remember, the domain of cosecant are all the values for which sine is not 0. So all reals except k pi, k not equal to 0. For secant, all the values for which cosine is not, you have to take away all the values of cos for which make cosine 0. So it's all reals except multiples of pi over 2. K can't be 0. The range, if you notice, the range is going to be, how can we write this? X less or y less than or equal to minus 1, y greater than or equal to 1. Same thing here. And the period, again, just by examination, you notice that it takes 2 pi units to go through the full cycle. So each of these have a period of 2 pi. And that concludes our discussion of the graphs of the 6 trig functions. On the next lecture, we'll talk about how they can look when they get transformed. All right, see you then. Bye.